All right, today we're diving into a huge story, and it's one that isn't really told in headlines, but in 60 years of data. We're going to unpack the story of India's changing climate and what that data is telling us. So let's start with a basic question, but one that's actually really tough to answer. How on earth do you even begin to measure the climate of an entire subcontinent? We're talking about a nation of over a billion people. How do you track if it's really changing? Well, the answer lies in the data. A lot of data. Take a look at this. It's showing us the temperature changes season by season, all the way from 1961 to 2020. Now, you can see how the individual years kind of bounce around, right? Some are up, some are down, but look at the overall trend line. There's just no denying it. It's pointing straight up. India is, without a doubt, getting warmer. Okay, so we've established it's getting warmer, but why? What's going on? To really get that, we need to look under the hood, so to speak, at the incredible engine that drives India's entire climate system. And it really all boils down to one single powerful force, the monsoon. And I want to be clear, we're not just talking about a rainy season here. This thing is a massive, continent-sized weather engine, and it's all powered by the unique way India is shaped. So how does this whole thing work? Let's break it down. It's basically a four-step dance. First, you get this intense summer heat building up over northern India. That creates a giant low-pressure zone. Think of it like a huge natural vacuum cleaner powered by the sun. Second, that vacuum starts sucking in all this cooler, wet air from the Indian Ocean. Third, as these moisture-packed winds push inland, they run into a wall. Two huge walls, actually. The Western Ghats and then the mighty Himalayas. And that brings us to the final step. The winds have nowhere to go but up. As they rise, the air cools and boom. All that moisture gets squeezed out, falling as the famous monsoon rains. Okay, so we've got the engine. Now, let's look at the warning lights. The data is showing us that this engine is starting to run hot. And here is a number you really need to see. 0.58 degrees Celsius. That's the average temperature increase across the entire country in just the last decade. I mean, from 2011 to 2020. Now, that might not sound like a lot, but for an entire country's average over just 10 years, that is an incredibly fast and significant jump. And this warming isn't some smooth, gentle slope. No, it's punctuated by these really extreme spikes. Just think back to 2010. That year went down in the record books for having the hottest summer in India's modern history. Let's actually go back to that 60-year graph for a second, because it shows this perfectly. See that really sharp peak right there? That's 2010. But here's the thing that's even more important. Look at the last couple of decades on that chart. See how those peaks, those spikes, are getting more frequent and taller? That tells us something critical. The climate isn't just getting warmer, it's getting more erratic, more unstable. But here's the catch with a national average. It's useful, but it can also hide what's really going on. The warming isn't happening evenly across the country. We're actually seeing a tale of two Indias. This table lays it all out. I mean, just look at the difference. Up at the top, you've got the Lakshadweep Islands, a whopping 0.87-degree jump. That's huge. And right behind them, you've got coastal areas like Tamil Nadu and a massive city like Delhi. But now, look all the way down at the bottom. The forested states in the northeast, like Tripura, it's barely a blip, a tiny fraction of the warming seen elsewhere. And that's the whole story right there, that incredible contrast. On one hand, you have these exposed, vulnerable island chains that are just baking. And on the other, a state with heavy forest cover that seems to be acting like a natural air conditioner, holding off the worst of the heat. It's literally two different climate realities happening at the same time, in the same nation. So you might be thinking, a fraction of a degree here, a degree there, why does this really matter? Well, it matters because these seemingly small changes have massive knock-on effects for the two things we literally can't live without, food and water. Yeah, these numbers aren't just abstract figures on a chart. They translate directly into real-world pressure on the systems that are supposed to provide food and water for 1.4 billion people. The stakes couldn't be higher. A major climate risk report points to this huge vulnerability up in the north. You've got the three great rivers, right? The Indus, the Ganges, and the Brahmaputra. I mean, these are the lifelines for hundreds of millions of people. And their source? Himalayan glaciers. The problem is, those glaciers are melting. The report says we might see a short-term boost in river water from all the melting. But then, by the 2050s, the flow is expected to actually go down. That puts in unbelievable amounts of pressure on the water supply. And you know what happens when you have less water and more heat? It hits our food supply. That same report lays out a really stark projection, a potential 5 to 15% drop in the yields of major crops by the 2050s. And that's if we don't make some serious changes. This isn't some far-off what-if scenario. It's a direct threat to the food on the table. And ground zero for this risk is the Indo-Gangetic Plain. We're talking about one of the most important breadbaskets on the entire planet. It churns out a massive amount of the world's wheat and rice, and those very crops, the staples that feed millions, are now squarely in the crosshairs of rising temperatures and dwindling water. So let's zoom out. What does all of this tell us about the future? When you put it all together, the data paints a really clear and frankly challenging picture of what India is up against heading towards 2050. There's a term we absolutely need to get our heads around, and that's heat stress. This is more than just feeling a bit hot and sweaty. It's a serious medical condition. It happens when it's so hot and humid that your body literally can't cool itself down anymore. Your natural air conditioning system just fails. And for anyone who has to work outside, this is incredibly dangerous. And of course, this has a huge economic impact. Take a look at this chart. By just 2030, countries across the region, especially India, are projected to lose a huge number of work hours because of this heat. Just think about the backbone industries, farming, construction, jobs that have to be done outside. When it's too dangerous to work, productivity just grinds to a halt. So let's connect the dots one last time. It starts with a hotter, more unstable climate. That puts a huge strain on water. That, in turn, threatens our food supply and our ability to work. You see how it's all connected? It's a chain reaction, and the ripple effects are just massive. And so all this data, all these charts and numbers, they all lead us to one final massive question. A question that is, frankly, one of the biggest of our time. As the very climate that has sustained life for millennia begins to change, how will a nation of 1.4 billion people adapt to this new, hotter, and much more uncertain world?